So, hi, hello everyone, welcome to Raaonline. This is Dr. Srivatsan, your faculty for Biochemistry, and in today's session we will be discussing about enzyme kinetics and various factors which affects the enzyme activity. And if time permits, we will try to cover up the Lineweaver-Burke plot and its significance too. So, we just move on into the topic, right? Now, please listen to this topic because this topic is more about theory. And this theory, I will try to present it in a more conceptual manner so that you tend to remember all those kind of things. So, this is a very dry topic, and if you are not listening in a in a more concentrated way, you are not going to get the point, you are not going to follow any of the points in this topic. So, please be listening to this topic in a more concentrated way. Right? So, let's make this topic interesting. Clear? So, we move on into your topic now. Now, consider as a beaker is there. You take some enzyme mix in that beaker. So, you add some amount of substrate into that beaker. Clear? So, after this what happens? This enzyme will be having some active sites. So, this substrate will go and bind to that active site. Okay. Upon binding with the active site, there will be formation of what? Enzyme substrate complex. And finally, from the enzyme substrate complex, there will be dissociation of enzyme as well as product. So, this is what happens in a normal enzymatic reaction. Now, consider the speed, the velocity with which this reaction is proceeding as V, and consider the substrate concentration as S. Now, the same beaker, you add some more concentration of the substrate. You are slowly or gradually increasing your substrate concentration. So, the reaction in this is taken forward. It is a forward reaction. So, in a forward reaction, the velocity is the movement of that reaction towards the formation of product. Now, imagine the scenario, you are slowly increasing the concentration of the substrate. So, once you slowly increase the concentration of the substrate, what do you think the velocity will happen? Any guesses? The velocity will increase. Why it should increase? Because I said that beaker is having a fixed amount of enzyme. So, all these enzymes will be having numerous number of active sites. If during the first pinch you have added this enzyme, right, the concentration of the enzyme is much low, very close to that of 0. At that time what happens? There will be more amount of enzyme which will be present. Okay. At the same time, more amount of enzymes means what? It means more amount of active site of the enzymes. If there is more amount of active site of the enzyme, the substrate, the concentration is much lesser. They come and bind to that active site and the forward reaction is getting carried out. Now, you slowly increase the concentration of the substrate. It means what? Once you increase the concentration of the substrate, the number of substrate binding to the active site increases. So, the number of substrate binding to the active site increases means what? Your reaction is getting forwarded in a much faster way. So, the velocity increases. So, the velocity slowly increases. Okay. After a certain point, what happens? This velocity will reach a plateau. And after that, it will not increase at all and it will remain stable at a single position itself. So, what is this point? This is the point at which all the enzyme active sites has been used up. It is not actually the case. See, this red line which I have mentioned here is called as V max. Okay, this is the maximum velocity. So, what do you mean by V max? V max is the one in which all the active sites of the enzyme has been bounded by the substrate. This is called as V max. You get the point? Right. And this small s is substrate concentration. So, up to a certain point, when you increase the concentration of the substrate, Up to a certain point, the line appears to be linear. But after that, the line has curved up and it has become stable. It means what? The velocity is not going to change even you increase the substrate concentration further. This is what is the meaning of this. Okay, the velocity of this reaction is not going to change at all, even if you increase the concentration of the substrate further than this plateau level. You get the point? Further than this level. So this is the maximum velocity. This is called as V max. You get the point? Fine. Now, with the help of this V max, we have another thing called as Km. What do you mean by Km? Km is nothing but substrate concentration at half maximal velocity. So it means what? It is nothing but the concentration of the substrate. Okay. So you take this full as the Vmax, this full as the Vmax, and you take the half of this. Say for example here. Okay. This is Vmax by 2. So you draw a line here and you connect that line with the x-axis. So you will be having a concentration, right? This concentration is called as Km. Clear? So this is called as Km of the reaction. Now we have an equation. So this equation is the most infamous Michaelis-Menten equation. Okay. So in this equation, what he has tried to find, he has tried to find the relationship between Vmax and Km in a reaction. So it is nothing but V naught, which is equal to the product of Vmax into substrate concentration divided by Km plus substrate concentration. So this is called as Michaelis-Menten equation. So this is an extremely important equation you need to memorize, guys, because we have lots of applications.